On this episode of Building the EMG-6, we're going to take a start-to-finish look at the process of manufacturing the wing ribs. The wing ribs on the EMG-6 are manufactured from half-inch 035 wall 6061 T6 aluminum tube. The wing ribs are preformed into the airfoil profile using a bending fixture, then inserted into special machine fittings located at both the forward and rear spar locations. This makes for an amazingly simple, lightweight, and rugged airfoil profile that is quick and easy for the builder to install. So let's start at the beginning. The airfoil on the EMG-6 is a NACA 23015 airfoil, and roughly translates to a NACA 23012 in the areas of the fabric sag between each rib. The aluminum tubing that forms the rib profile is bent on a special bending jig to form the shape of the NACA 23015 airfoil. And after bending each rib, the profile is matched against a master airfoil template to ensure its accuracy. Although you can simply purchase all of the pre-bent ribs from the web store, eliminating this step in the building process, we're going to show you a couple of other options. You can purchase or even rent the bending jigs and bend and cut your own ribs from aluminum stock tubing. More importantly, we're going to show you how you can make your own bending jigs and bend all of the ribs yourself. The reference drawings that you will need are located on the Builder's Database under Chapter 57, which is for the wings. The master folder for wings also contains 5770, which contains the folders and the files for the wing rib subassembly. In folder 5770, 08, 09, and 10, these are the individual folders containing DXF files as well as PDF drawings for each of the templates that will be necessary for manufacturing the ribs. The PDF drawings contain all of the information necessary for you to take a scrap piece of plywood or MDF and lay out accurately the bending profile for each jig. Once the profile has been transferred to the board, you can cut the bending jig using a bandsaw or jigsaw. Another option would be simply take the DXF files to a local printer like Kinko's and have the DXF files printed onto paper at 100% scale. You can then simply glue the piece of paper to a piece of MDF or plywood and use the paper template as a guide for cutting out your bending jig. If you're making this template at home, you can eliminate all the lightning holes. They've been placed on the factory manufactured bending jigs simply to save weight and shipping costs. Once you've cut out the bending jig, you will need to make a small strap that will hold the aluminum tube during the bending process. It should hold the tube snug against the bending fixture while still maintaining enough slack to be able to insert and remove the aluminum tubing. We've modified this design slightly and incorporated a latching fixture which is adjustable. With each aircraft having 44 ribs, this makes the mass production process a little bit more efficient. We simply insert the tubing and apply light pressure to the locking clamp, and we're ready to begin the bending process. There are many ways to accomplish the bending task. Vertically or horizontally clapped to the workbench works very well when you're trying to accomplish this by yourself, as you can use the tabletop as a guide to prevent the tube from slipping off of the bending jig. With two people during the mass production process, working vertical seems to be the easiest and fastest way to bend the tubes. We will need to bend 22 ribs for the upper profile and then switch to the lower rib bending jig for the remaining 22 lower ribs. During the development of the bending jigs, it took several dozen attempts to get the profile exactly perfect. Because it's impossible to bend the area of the rib that's being held in the bending fixture, the profile had to be adapted to allow for additional material that could be clamped and then cut off later. As you can see in the SolidWorks drawing, the rib is designed so that there's approximately 0.9 inches of additional material that will need to be cut off before the insertion into the forward wing spar fitting. If we look at the lower section, down here we can see the step that is machined into the fitting. This is the step that bottoms out the rib and positions it correctly in relationship to the forward spar. This is the cutoff position that we're looking to achieve. After bending each rib, it's necessary to place the rib onto the airfoil profile and then mark the tubing at the intersection where the rib will bottom out in the spar attach fitting. This is pre-machined into the airfoil profile to make it very simple to position the rib tubing and mark for cutting. Also note that we will not be cutting off the trailing edge of the ribs at this point in time. This is because the wing is tapered and each rib is cut to a slightly different length. The trailing edge will be marked and cut to length after the rib has been inserted into the forward wing rib spar fitting, then using a combination square perpendicular to the rib and tangent with the forward edge of the rear spar marked and cut to length. So for now we're just going to mark and cut the leading edge of each one of these ribs until it's time for installation onto the wing. Using a cutoff saw or a bandsaw, cut the forward end of each of the upper and lower ribs. We have a slow turning metal cutoff saw for cutting steel and aluminum, which works really well. However, even a cutoff saw for wood will work adequately for small pieces of aluminum tubing like the rib. It's strongly recommended, though, that you use some method to clamp the tubing during the cutting process. More likely than not, if you've welded up your own fuselage frame, you have a cheapo Harbor Freight cutoff saw for cutting metal, which also works really well for this application. In this case, it will probably require that you deburr the end of the aluminum tube after cutting so that it will fit into the forward spar rib fitting. After cutting the leading edge of each rib, place it back onto the airfoil profile template and check for accuracy of the profile. Rather than making this template out of wood, printing the template on a piece of paper and then laminating it to a piece of foam board with contact cement makes it a little bit more manageable. Check the profile for both the upper ribs as well as the lower ribs. So there you have it. We've gone from start to finish on the process of manufacturing the wing ribs for the EMG-6. In the next video, we will go through the process of installing these ribs into the forward spar fittings and then marking, cutting, and installing each one of the ribs. This has been another episode of Building EMG-6. If you enjoy these videos and appreciate all of our efforts in putting them together, please like our video on our YouTube channel. And until next time, happy flying.